Service entrance conductors must be rated for the sum of the individual service panels they serve. In a situation with two 200 amp panels and one 100 amp panel, the service entrance conductors must be rated for at least 500 amps, calculated by adding 200 plus 200 plus 100. The capacity of a meter hub is independent of the main breaker's rating. You can install a 200 amp meter hub even if the main breaker is rated for 100 amps. The meter hub is sized to handle the total current flow, while the main breaker is sized to protect the loads served by the panel. Multiphase service heads are available to accommodate multiple conductors. You can find service heads designed to handle 6 conductors for your installation. You can run a single 4/0 American wire gauge or copper conductor in 3-inch polyvinyl chloride or PVC to support the 500 amp capacity. This may require a larger conduit but simplifies installation and reduces material costs. You can run 2 parallel 2 AWG copper conductors and 3/4-inch PVC conduits to achieve the same 500 amp capacity. This uses smaller conduits but requires more labor. Service entrance conductors must be protected by overcurrent devices, such as fuses or circuit breakers, rated for at least 500 amps. A proper grounding system is essential for the service entrance equipment and all electrical equipment in the building. All electrical equipment, including the meter hub, service panels, and overcurrent devices, must be clearly labeled for safety and identification. The installation must comply with all applicable electrical codes and local regulations. In calculating the minimum size of service entrance conductors, you must account for the total connected load served by all panels. This calculation should follow the guidelines outlined in the National Electrical Code, or NEC. Consider demand factors, which allow for a reduction in the calculated load based on the likelihood of all connected loads operating simultaneously. Demand factors are specified in the NEC and vary depending on the type of load. The NEC provides tables to determine the ampacity of conductors based on their size, insulation type, and installation method. Ensure the chosen conductors have sufficient ampacity for the calculated load. If running parallel conductors, ensure they are of the same material, size, and length, and are terminated in the same manner. The overcurrent protection device must protect the conductors against overloads and short circuits. Select an overcurrent device with an interrupting rating sufficient to handle the available fault current at the service entrance. Grounding ensures a safe path for fault current to return to the source, minimizing the risk of electric shock. Install a grounding electrode system that complies with NEC requirements, which may include a grounding electrode conductor connected to a ground rod, water pipe, or other approved grounding electrode. Bonding ensures that all metallic parts of the electrical system are electrically connected to create a low impedance path for fault current. Bond the meter hub, service panels, and any other metallic enclosures to the grounding system. Proper labeling is crucial for safety and maintenance. Clearly label each service panel with its voltage, amperage rating, and the loads it serves. Label all overcurrent devices with their amperage rating and the circuits they protect. Adhering to the NEC and local electrical codes is mandatory to ensure a safe and compliant installation. Consult with a qualified electrical inspector to ensure compliance with all applicable regulations. When selecting a meter hub, ensure it is rated for the appropriate voltage and amperage. The meter hub must be compatible with the type of meter being installed. The service head, also known as a weather head, protects the service entrance conductors from the elements. Choose a service head that is suitable for the number and size of conductors being used. The service entrance conductors must be properly supported to prevent strain on the connections. Use appropriate clamps and supports to secure the conductors to the building. Seal all conduit entrances to prevent moisture from entering the electrical system. Use duct seal or other approved sealant to seal the conduit openings. Inspect all connections to ensure they are tight and secure. Loose connections can cause overheating and electrical problems. After completing the installation, test the system to ensure it is functioning properly. Use a multimeter to verify voltage and current readings. Document the installation, including the size and type of conductors, the rating of the overcurrent devices, and the grounding system. This documentation will be helpful for future maintenance and troubleshooting. Consider using a surge protective device, or SPD, to protect the electrical system from voltage surges. An SPD can help prevent damage to sensitive electronic equipment. If the service entrance conductors are exposed to physical damage, protect them with conduit or other suitable means. Ensure that the work area is clean and free of debris. Remove any tools or materials that could pose a hazard. De-energize all circuits before working on the electrical system. Use a voltage tester to verify that the circuits are de-energized. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Follow lockout/tagout procedures to prevent accidental energization of the circuits. Work safely and carefully to avoid electrical shock or other injuries. If you are not qualified to perform electrical work, hire a licensed electrician. Consider future expansion when sizing the service entrance equipment. It may be wise to install a larger meter hub and service panel than currently needed to accommodate future loads. Use corrosion-resistant materials, especially in damp or corrosive environments. Copper conductors are generally preferred for service entrance applications due to their excellent conductivity and corrosion resistance. Aluminum conductors can be used, but they require special connectors and installation techniques. Consult the NEC for specific requirements regarding the use of aluminum conductors. Ensure that the conduit is properly sized to accommodate the conductors. The NEC specifies the maximum number of conductors allowed in a given size of conduit. When bending conduit, use a conduit bender to avoid kinking or damaging the conduit. Sharp bends in conduit can reduce the ampacity of the conductors. Support the conduit at regular intervals to prevent sagging or damage. Use appropriate hangers and supports to secure the conduit to the building. Avoid running conduit in areas where it is likely to be damaged. If necessary, protect the conduit with a guard or barrier. Ensure that the service entrance equipment is accessible for maintenance and inspection. Do not block access to the meter hub, service panels, or other equipment. Keep the area around the service entrance equipment clear of obstruction. Provide adequate lighting in the area around the service entrance equipment. This will make it easier to perform maintenance and inspections. Regularly inspect the service entrance equipment for signs of damage or deterioration. Repair any damage promptly to prevent electrical problems. Keep the service entrance equipment clean and free of dust and debris. Dust and debris can accumulate and cause overheating. If you are unsure about any aspect of the installation, consult with a qualified electrical engineer or inspector. It is always better to be safe than sorry when it comes to electrical work. Consider using energy-efficient lighting and appliances to reduce the overall load on the electrical system. This can help save energy and reduce your electricity bill. Educate occupants of the building about electrical safety. Teach them how to recognize and avoid electrical hazards. Provide them with information on what to do in case of an electrical emergency. Install smoke detectors and carbon monoxide detectors in the building. These detectors can help protect occupants from fire and carbon monoxide poisoning. Develop an emergency plan in case of a fire or other electrical emergency. Make sure everyone knows what to do in an emergency. Conduct regular fire drills to practice the emergency plan. Keep a fire extinguisher readily available in case of a fire. Ensure that the fire extinguisher is the proper type for electrical fires. Have the electrical system inspected regularly by a qualified electrician. This can help identify and correct potential problems before they become serious. Keep accurate records of all electrical work performed on the building. This will be helpful for future maintenance and troubleshooting. When replacing electrical equipment, use equipment that is rated for the same voltage and amperage. Do not use equipment that is undersized or overloaded. If you are adding new loads to the electrical system, make sure the existing service entrance equipment is adequate to handle the additional load. If not, you may need to upgrade the service entrance equipment. Obtain all necessary permits before starting any electrical work. This will ensure that the work is done in accordance with local codes and regulations. Notify the utility company before disconnecting or reconnecting the service entrance conductors. They may need to disconnect the power to the building. Use only approved electrical materials and equipment. Do not use substandard or counterfeit materials. This could create a safety hazard. Follow the manufacturer's instructions when installing electrical equipment. Improper installation can void the warranty and create a safety hazard. Use a torque wrench to tighten connections to the proper torque. Over-tightening or under-tightening connections can cause problems. Protect the service entrance conductors from sunlight and weather. Sunlight and weather can degrade the insulation on the conductors. Install a lightning protection system if the building is located in an area prone to lightning strikes. A lightning protection system can help protect the building and its occupants from lightning damage. Ground the lightning protection system to the same grounding system as the electrical system. This will help ensure that lightning currents are safely dissipated. Inspect the lightning protection system regularly to ensure it is in good condition. Repair any damage promptly to prevent lightning damage. Consider using a smart meter to monitor energy consumption. A smart meter can provide detailed information about energy usage, which can help you identify ways to save energy. Use a power quality meter to monitor the quality of the electrical power. A power quality meter can detect voltage sags, surges, and other power quality problems. Correct any power quality problems promptly to prevent damage to electrical equipment. Install a backup generator if you need to have power during a power outage. A backup generator can provide power for essential loads, such as lighting, refrigeration, and medical equipment. Size the backup generator to handle the expected load during a power outage. Have the backup generator serviced regularly to ensure it is in good working order. Store fuel for the backup generator in a safe and secure location. Follow all safety precautions when operating the backup generator. Never operate the backup generator indoors or in an enclosed space. This could cause carbon monoxide poisoning. Use a transfer switch to safely connect the backup generator to the electrical system. A transfer switch prevents power from the generator from backfeeding into the utility grid. Label the transfer switch clearly to indicate its purpose. Test the transfer switch regularly to ensure it is working properly. Keep the area around the transfer switch clear of obstructions. Provide adequate ventilation for the backup generator. This will help prevent overheating. Install a carbon monoxide detector in the area where the backup generator is located. This will help protect against carbon monoxide poisoning. Educate occupants of the building about the proper use of the backup generator. Teach them how to start, operate, and shut down the generator safely. Provide them with information on what to do in case of a power outage. Keep a flashlight and a battery-powered radio readily available in case of a power outage. These items can be helpful for communication and safety. Stay informed about weather conditions and potential power outages. This will help you prepare for a power outage. Have a plan in place for dealing with a power outage. This will help you stay safe and comfortable during the outage. Check the batteries in smoke detectors and carbon monoxide detectors regularly. Replace the batteries at least once a year or more often if needed. Keep a first aid kit readily available in case of an injury. Make sure the first aid kit is well stocked and that everyone knows where it is located. Know the location of the nearest hospital or emergency room. This will be helpful in case of a medical emergency. Have a list of emergency phone numbers readily available. This list should include the phone numbers for the police, fire department, ambulance, and poison control center. Teach children how to call for help in an emergency. Make sure they know their address and phone number. Practice emergency procedures with children regularly. This will help them know what to do in an emergency. Stay calm during an emergency. This will help you make rational decisions. Provide support and comfort to others during an emergency. This will help them cope with the situation. Remember that safety is always the top priority. Take all necessary precautions to protect yourself and others from harm. If you are not sure about something, ask for help. It is always better to be safe than sorry. Always comply with the most recent version of the NEC and local codes.